In this video, I'll show you how to design a superelevated roadway that uses axis of rotation pivot points. This drawing contains a surface, an alignment and profile, and a corridor assembly. First, I'll calculate superelevation along the alignment. I'm going to select divided crowned with median as the roadway type. And then, for the pivot method, I'll select median edges. Some pivot methods enable you to specify whether to maintain the median shape or to distort the median as the roadway superelevates. When using the median edges method, the median cannot be distorted. For the lanes, you can specify a default width and slope. For the shoulders, you can specify default width and slope values, as well as how you want the shoulders to behave, whether they are on the low side or high side of the superelevated roadway. I'll also specify that the shoulders on both sides of the road be included in the calculation. I'll accept the default superelevation attainment settings and then start the calculation. The results of the calculation are shown in the Superelevation tabular editor. You can modify the data in this table as needed. Also notice that the alignment now has labels that indicate the superelevation critical stations. Now, let's look at the assembly. To create the lanes, I used the Lane Superelevation AOR subassembly. This subassembly fully supports superelevation axis of rotation pivot points. Other subassemblies vary in their ability to contribute to the superelevation calculation. Let's look at the subassembly parameters. First, notice that the assembly type value is divided crowned road. That is the roadway type I specified when I calculated superelevation on the alignment. You can specify another value, but it should match what is set on the alignment. Notice that the assembly was composed using a separate group for each side. Some pivot methods will not work properly if the assembly is composed as a single group. Finally, each of the superelevation parameters must be set in specific combinations to accommodate the specified roadway type and pivot method. These settings are described in the AutoCAD Civil 3D help system. For example, the inside and outside point codes determine whether a point can be used as a pivot point. The flags indicate potential pivot points on the assembly. Depending on the specified roadway type and the subassembly parameters, the assembly has the ability to pivot about any of the flagged points. Now, I'll use the assembly to build a corridor along the alignment. Now, let's use the section editor to view the corridor at various superelevation critical stations. Notice that the median edge offset and elevation values do not change as the road superelevates. The median edges were specified as the pivot points, so they remain at a fixed elevation. Note that I used a flat profile so that you can clearly see the elevation points are maintained. Notice the difference in behavior between the shoulders on the high side and low side of the superelevated section. As I specified in the Calculate Superelevation wizard, the shoulder on the high side maintains a consistent slope, while the shoulder on the low side matches the slope of the adjacent lane. You can modify the alignment's superelevation criteria parameters on a curve-by-curve basis. For example, you can change the pivot method for one curve without having to recalculate superelevation on the entire alignment. Now, the road pivots about the inside of this curve, while the other curve still pivots about the median edges.